Alright, welcome back ladies and gentlemen. Now we're on 1.0 day 2, critical mathematical skills still. Okay, now we're going to be translating words into mathematical expressions and solving one-step and two-step equations. Okay, so let's get going. Translating words into math expressions. Several words and phrases apply addition, some of them are. Well, there's a bunch, but let's just take a few. Let's do some obvious ones first. Well, if I say add, of course that implies addition. I might say plus. Okay, if you think about what the answer to an addition problem is, we use a fancy word that I call the sum. Alright, and then, well, you can kind of cheat and look down here a little bit, but we can say increased by, or we can say more than, and there are several other options. So, kind of etc. there on that. Alright, so if we want to write the one of these phrases as a math expression, some number increased by 13, well, some number, that's just going to be a variable. And if we don't specify the letter, feel free to choose whichever one you like. Okay, I'm going to choose x in this case. So my sum number is x, and then increased by 13, well, it just means adding 13. So there's my final answer there. Okay, and then something like 5 more than the number of cats. Well, the number of cats, again, is the kind of unknown here, so I'm going to use that as a variable, and cat sounds pretty good. I'll use a c. And then it says 5 more than. Well, again, more than means addition. Be careful about the phrasing here. Phrasing like this, the English and math don't get along real well. The order's kind of backwards. So if I say 5 more than the number of cats, it means I'm taking the number of cats and then adding 5 onto that. So just be careful about how things are phrased, but there you go. Alrighty, carrying on the basic theme here, subtraction words and phrases. Again, there are several different types. I'm not going to list every single possibility here, but some easy ones to start out with. Well, of course, if we say minus, that means subtraction. And I could subtract, but I'm not going to bother listing that. We could say less than. If you have less than somebody else, you're subtracting to find out what you have. Or something like maybe decreased by. Or again, one of my personal favorites, the answer to a subtraction problem is called the difference. And again, etc. We can come up with more, but let's not spend all day listing those. Same thing with multiplication. Well, of course, one of our more popular ones, we could say times. Again, of course, we could say multiply. I won't bother writing that. Just another one I'm going to list real quick is the answer to a multiplication problem is a product. So that's another one. And again, we could probably come up with some more, but let's keep this thing moving. Okay, division words. Alright, well, divide by, that'd be an easy one. The answer to a division is a quotient. So that's one that implies division, or sometimes one that's not really thought of very often, we can say ratio. Okay, and again, we could keep going with those probably, but let's leave it at that for now. So just a few quick examples. If I say the product of x and y, well, here I'm specifying what letters to use, so no big deal. So I just have to write the x and the y, and actually what's nice about this is I don't have to write anything else. So I would be happy with x and x, y, or of course if you'd like to do something else, you could do the x and then that little dot to imply the multiplication right there, but whatever works for you. Okay, the number of frogs reduced by 9. Okay, well again, frog seems like my variable here, so I'm going to use an f for that, and then reduced by 9, so I've got some number of frogs, and I'm going to subtract 9 from that. Alright, 12 less than x. Okay, again, notice that phrasing less than. Okay, this is one of those things where, again, English and math don't get along with each other that well. If I say 12 less than x, what most people tend to write is 12 minus x, but that's not really what's going on. So, bad, frowny, we don't like it. Okay, 12 less than x, if you think, well, 12 less than 20, well, that's 8, because you would take the 20 first, then minus the 12. So anytime I say 12 less than x, or any similar phrasing to that, you have to do kind of the end of it first, then subtract the beginning of that little phrase. So 12 less than x is really x minus 12. Okay, and then the ratio of sheep to goats. Okay, again, as soon as you say ratio, that's again one of our keywords for division. And then sheep to goats, so let's use S and G, although you don't have to. Be careful with S's, because if your handwriting is such that it looks like a 5, it might be a dangerous thing to use. So I'll use a cursive S, because my S's do kind of look like 5, so I don't use that. So I could do S colon G, but usually in math that doesn't make a whole lot of sense. So one of two things would probably be better, is just to write the S, then the actual division sign, the G, I'd accept that, or what could be really, really nice is to do s on top and then g on the bottom of a fraction, because remember, a fraction bar implies division as well. Alright, well, as it says here, beware of words and phrases that imply exponents. Well, if I've got a number squared, well, let's use n for the number this time. It'll be fun. And, of course, squared is a power of 2. So, there you go with that. 5 cubed, well, that's a 5. And then cubed is the third power, so I'll put a little exponent 3 on there. Okay, now notice here I'm not asking you to work it out, I'm just asking you to write it. Of course, that is something we could work out if we wanted to. Okay, and then the amount of energy raised to the 5th power. Okay, energy, I'll use an E for energy, and then raised to the 6th power. Well, hopefully this one's a little more obvious, and put a little 6 on that guy, and then we're done. Alright, well, sometimes more than one operation is applied, so just be careful so you write things in the right order. Alright, so 3 less than the quotient of 4 and x. Okay, well, again, remember there's that phrasing, the less than, so we're actually going to do things backwards. So first of all, we're going to start with the quotient of 4 and x. Okay, now, I admit saying the quotient of 4 and x, to me, it leaves it a little bit up in the air. Is it 4 over x or x over 4? But quite honestly, a very standard way of writing this, it seems to be the basic rule. When you see this, you put the 4 on top and the x on the bottom. So first on the top, second on the bottom. So put the 4 over the x, and then if I'm doing less than, that's a subtraction, and 3 less than, so it's a minus 3. So that's what that guy looks like, turned into math symbols. And then here, let's do a physics one. We've got acceleration times time, so be careful about that. Increase by the velocity. Times means multiplication. Time is actually going to be one of our variables. So acceleration, I'll use an A, and then I'll use an actual dot for the times time, so I'll use a T right there. Depending on your handwriting, you might want to do some little hook or something like that on the T to make it not look like a plus sign. And then increased by, well, there's a plus, so plus. So especially here, if I had a T that looked like a plus and a plus sign next to it, that'd be very confusing. And then velocity, I'll use a V. So I've got A times T plus V. Of course, that dot is optional. You could have just written AT plus V. Either one of those would be fine. Alright, now let's shift gears into equations. Okay, for 1- and 2-step equations, the goal of solving any equation is to take an equation and get the variable by itself. And of course the variable is just the letter. Okay, your final answer should always be, I'm just going to use the letter x here, but it should be whatever variable you have equals some kind of a number. Okay, hopefully you're okay with that being number, but if not, there you go. Okay, so basically I'm going to do stuff until I have the x by itself on one side of an equal sign, and then I'll have a number on the other, and that's when I know I'm done. Okay, now these first two are 1-step equations. If I have x plus 4 equals 12, basically the idea, and hopefully I'm not telling you anything you don't know right now, is to undo whatever operation is with the letter. So since this is a plus 4, I need to do a minus 4 because addition and subtraction are opposites of each other. Okay, and the whole point is those two guys cancel, leaving me with the x by itself, so that makes me very, very happy. And then 12 minus 4 is simply an 8. Okay, now I'm done because the x is by itself, numbers on the other side. Alrighty. Moving on here, I've got 4x. Remember, if I write two things next to each other in math, and I don't put anything else in the way, it means multiplication. And the opposite of multiplication is division. So here I'll divide by 4. Okay, remember, always do it to both sides. These 4's cancel, and now the x again is by itself. Remember, there's really a 1 in front of that x, but most of the time we don't bother to write that. Alright, now 12 divided by 4, of course, is a 3. And again, the x is by itself, so now I'm happy. Moving on. Alright, here's a couple things that sometimes mess people up. We've got 5 equals d minus 8. Okay, now sometimes having the variable on the right makes people's heads explode. Now, hopefully that doesn't happen to you. But the basic rule is the same. Well, I want to do whatever I need to do to get the variable by itself. So look at the side with the variable on it, in this case the right side, and undo whatever is on that side. So now a minus 8, I need to undo that with a plus 8, again doing it to both sides. 5 plus 8 gives us a 13. There's my equal sign. The 8's cancel and leave me with a d. Okay, now if you're like me, looking at it that way makes my brain hurt a little bit. But the nice thing about equal signs is you can read them either way. So instead of saying 13 equals d, I could, if I wanted to, turn them around into d equals 13. And I don't know, that just feels better to me. Alright, going to our second example here, I've got x over 3. And, okay, again, since it's x over 3, that's a division, so what I need to do is multiply by 3. Okay, now if you're good with fractions, and you think of it as 3 over 1, that's probably a good way to do it because those guys cancel that way. So the top always cancels with the bottom. Okay, of course we want to do that to both sides as well. And again, if it helps you to think of those as all as fractions, that's great, but if everything has a 1 denominator, it's really unnecessary. See here, I didn't have 1 denominator for both, so it was kind of nice to think of it that way. But whatever the case here, the x is now by itself. And now I've got a negative 9 times 3, and negative 9 times 3 is negative 27. Again, the x is by itself, so I know I'm done. Alright, let's transition into two-step equations. Okay, the good rule of thumb for two-step equations is do order of operation backwards. Okay, so I'm doing order of operations. The last thing that I normally do is addition and subtraction, so that's going to be the first thing that I undo in these equations, provided I can actually get to the addition or subtraction, and in this case I can. So I've got a multiplication here and an addition here, so I want to undo that addition first. So I subtract 11 off on both sides. Again, those two guys cancel, leaving us with a 3x on the left-hand side, and I've got negative 4 minus 11 over here, and that gives me a negative 15. Alright, now what I've done is I've turned my two-step equation into a one-step equation. So hey, now this is hopefully easier. Okay, again I've got 3 times x, so I use division to get rid of those 3's. X is by itself, negative 15 divided by 3 is negative 5. Alright, moving over here, again, don't freak out when you see the fraction. Again, same basic idea, I want to get rid of any adding, subtracting before I get rid of any multiplying or dividing. So I see a minus 7 right there, so first thing I do is plus 7 to both sides. Alright, again, those guys cancel, that's the point, leaving me with an n over 4 equals 15 and 7 is 22. Okay, and again, in case it helps you, think of everything as a fraction. Now I'm going to multiply by 4, and again, technically 4 over 1, so those two guys cancel, leaving the n by itself. And then, of course, I have to do that to both sides. 22 times 4 is 88. And there you go. Alright, now please give these 3 a try. Of course, look back at the notes that we just did to give you a little bit of hint in case you need it. But otherwise, we'll talk about these to open up class. See you then.